it off and pass it over to you. Welcome to Equal Experts Talks Online. I'm Lisa Copeland, SVP of Strategy here at Equal Experts. This evening is our second session in our security series where we've been covering a diverse range of topics. Tonight, we're going to be exploring OWASP Top 10 with Robert MacLean. And you heard a little bit about the origin of it while we've been teeing this up. In this lightning talk, we'll introduce the top 10, an industry guide to the biggest security issues facing web applications. We're really excited to welcome Robert, so thank you. He's a tech lead here at Equal Experts South Africa. And then after Robert's talk, we're gonna run a fishbowl with a couple of really great people. We have Grant Ongers. He is also a security consultant here at Equal Experts and on the OWASP Foundation Global Board of Directors. Zoe Braderman, thank you for joining. She is part of the OWASP Foundation and the New York City chapter leader. And Brian Glass, assistant professor of computer science at Union University, Jackson, Tennessee, and project lead OWASP Top 10. Now a quick conversation just around meeting protocols. You can start adding your questions now using the Zoom Q&A function. We'll be answering the top voted questions, so keep an eye on what questions are being added and vote for those you'd like to see cover. And now, Robert, I'm going to hand it over to you.
Right, thank you so much. Sorry, I had inevitable tech problems again. I seem to not be good at this. Getting slicing things going. So this is going to be a lightning talk on top 10. My whole screen just flickered, right? And flick it again. Hi, technology and me are not friends. Hopefully you can still hear me.
We can hear you.
Cool.
And you look fabulous, by the way, too.
Thank you.
I really like the tie, your bow
tie. Yeah, it is a normal thing for me every day at work to wear a bow tie. It brings normality to my life. So, right, as I was introduced, I'm based in Cape Town. In addition to my day job at Equal Experts, I also help run communities. I run a conference for software developers called DevConf, and I'm available on Twitter, and I have a blog that I update once a year, more or less. And I have a dog who's staring at me lovingly to jump onto my lap. So if I suddenly get knocked over in the next talk, you'll see that. You may notice on the screen there's a little floating clock here. I've built this talk previously, and it's 90 minutes long, and then I got asked to do it here and told, can you make it 30 minutes, which is great, because that's possible. It's only like 32 slides still, so that's a slide a minute. So I thought I would treat this like one of my favorite things to watch, which is speed runs. So I'm going to be speed running this and hopefully get this done in 30 minutes. So I'll start now. And if I do get it done in 30 minutes, you are required to clap. I know you're at home and it'll be weird, but just go with it. Trust me. I will know from here. And if I don't get it done in 30 minutes, you don't have to clap. And that's, I think, fair trade for the time. Obviously, there is a bit of this that is around hacking, right? And security. And don't try this at home is really the thing. I don't get to work on Mythbusters. I never get to tell people this. So this is my one chance in my career to tell people, don't try this at home. So don't. Do this where you're allowed to and have permission. So what is the top 10? We briefly got an introduction to what OWASP is. So the top 10 is their set of guidance. It is focused mostly on web security, but it is kind of broadly applicable to other aspects. And I'll talk about that as I go through the slides and the content. I built this presentation based on the 2017 guidance. So it gets updated on a sort of regular basis. The 2020 guidance is currently being built. The call for data is open until November, so you can submit into that. And really it looks at sort of 10 areas that are that big. What are the things we care about? What are the things to look at? And what is that sort of minimum bar for security that you want to have? And they sort of rank and score it and come up with it. And the great thing is it's all based on real feedback. So this isn't just like me sitting there going, oh, I really just don't like cross-site scripting. I'm going to put in there. This is real things that impact real people throughout the whole site. So let's move on. Look at that. I'm way ahead of schedule. Right. So we'll go through the list. We're going in reverse order because it gets more interesting at 1 than it is at 10. That's literally the only reason for it. this is on the right here, a screenshot of the guidance, and it's fantastic in the way you get it presented. You've got the scoring there, so how easy is it to exploit this? How prevalent it is? How hard or easy is this to detect this, right? How hard is it to correct this? And that gives you a sort of base for it. It explains how you are vulnerable. It explains how you can grant and gives you scenarios. And it's such a great guidance. It's approachable. It's really easy to read. I will have the scores for the rest of these in the bottom right-hand corner, probably under this. So I'll move that up a little bit. But it is available if you're interested. I won't talk to it too much. So what is number 10? Number 10 is one of the more boring ones from a presentation perspective because there's not a lot to show and talk about. It's having enough logging and monitoring, right? It's about having logs when things are weird, right? Suddenly you get a whole bunch of failures and people not being able to get into accounts and one account's getting targeted, or suddenly you have a big transaction or a big sort of shopping cart. Normally you have 5 things in your shopping cart and suddenly you get someone doing 100 things in your shopping cart. These should all be alerts and be in your logs so you can trace them. And the reason for that is so that you can go back and determine what's going on, so that you can pick up things that are happening on your network. And it sounds really basic, but a lot of the stuff kind of is. If you're a part of this talk tonight and you're watching, you probably know these things. These are just reminders and refreshers. There are some things you might not know, right? So like, don't put the logs on the same box as it's used on, right? Where I work, we use Cabana. So we take our logs and we push them into Cabana and they go there and that's nicely secured. And then an attacker can't get into those and manipulate them, right? They could maybe throw a lot more logs at it and try to like drown it out, but we can pick that up easily. If you keep them on the machine, people will get into them, they'll mess with them, right? And you know, if you look at the examples here, they talk about like, hey, if you go into and set up your logs, don't go in and have your logs turned off for like pen tests, because obviously if an attacker is attacking you, it's going to look like a pen test. So it's not going to catch anything. The most important thing here is not just like have logs for the sake of having them, it's being able to use them. So build alerts on top of them. If you're working with things like CloudWatch on AWS or Stackdriver on GCP, it's really easy to create alerts off your logs. And why does that matter? Because that matters about time to recovery. So somebody gets into your network and is looking around and doing something and they can trigger something in your logs that seems weird, then you can respond to that quicker. And that will lower how much damage gets happened. It may save your entire network. You know, we've seen attackers with ransomware change over the last few years going from like they get onto your network and then they just like encrypt everything and try and ransom your network back to you for some Bitcoin. Now they get onto your network and they stay there for a while and try to get everything off and try to get more information. And when they're done messing with you, then they're ransom, right? If you can pick them up early with logs and alerts, that can really save you. So it's not particularly glamorous, and it's not one that's really that fun to demo, but it is really useful. And you'll see a lot of these interlinks, so we'll come back to logs later on as well. Right, and hey, slide, next one, cool. So number 9 is components with known vulnerabilities. This gets drummed into us all the time, like make sure you patch your Windows machine, make sure you patch your SQL Server. We know this, it's really basic stuff, but we sometimes just help to get reminded. So don't be deploying software into production that has problems, right? So obviously our OS matters, and that can also include not just if you're running like Windows, but your Docker images. What are you building your base Docker images on? Are you using some Docker image that's 6 months out of date? And that could be a problem. Because obviously that will if somebody can get into that, they can really compromise. More importantly though, nowadays, at least in my opinion, is what you depend on. So if you are using things like Maven with Java or NPM or Yarn to get your dependencies, that third-party code, that runs as your code and can like get into your system and mess with you. And it's probably, you know, if you're on like JavaScript development today using like React or Vue, that's probably okay. But it depends on stuff. And those things depend on things. And it goes all the way along the supply chain of dependencies. And all it takes is for somebody to attack somewhere far down the supply chain for that security flaw to flow all the way through. And then your code is blocked and damaged. And so you can use tools like dependency check, which is a free tool from OWASP that actually checks your dependencies. I use this every day on my project because we use some JVM stuff. And you're able to use that and pick up, oh, these dependencies, these things I rely on, they are being compromised and I need to get new versions in. And it's really, really useful. If you're on a cloud provider like GCP or AWS, they do container scanning. So you can get your containers scanned really easy. It's like 3 clicks. I could figure it out, which tells you how easy it's got to be, right? So it is really worthwhile doing. And it's worthwhile putting this into your pipelines so that you don't deploy to production with these. Have these things automatic. Don't rely on like you're on call in your team to like go through a checklist every Monday morning. Like, I need to check all the dependencies, okay? Because that will like get forgotten about and missed one day. And then you're not going to have the ability to like go back and fix it. So let's move on to number 8. So insecurity serialization. Now we get into the more fun ones from my perspective, coming from like a developer background, because these are, you know, the things before are obvious things we should do. We know that. Now we're talking about stuff like coding ones. And so what do we mean by serialization and deserialization first? Serialization is just taking some representation in your code, like a class or an object, for instance, and we turn that into some format that we can transmit somewhere. So a good example would be like in PHP, I'm going to take a whole bunch of details about you, and I'm going to turn it into a JSON object and put it in a string and put it in a cookie. So that next time you click on something, that gets sent back to me and I can deserialize it and I can maintain some state for the PHP app. Now that's great, and that's really useful to have. Insecurity serialization talks about the problem of here, what happens when somebody passes you something that content you, and it does something that you're not expecting. So I have a little explanation of this with JSON data here. So you can imagine I've got a little JSON data blob that comes in, and I expect it to look like that. Now, that will give me an object, if I deserialize it in JavaScript, with a property. That's fine. But an attacker could come and send me this, right? Now this is a self-executing JavaScript function, and it runs some code. For the sake of this demo, it's just printing something out to the console. But it could do anything in the user's context, right? Or in the context of the server, if it can run on like a node server or something. And that is massively more powerful, okay? And you're thinking, wow, that's weird. Like, that doesn't look like JSON. How could that happen? And that all comes down to what parser you use. So if you're doing something like JSON.parse, you're pretty safe. Like, using a good parser is a good idea on this. But you could parse both of these with eval, and they will succeed in generating things. And the first one creates an object, and the second one creates an object and also runs code, right? And so it really comes down in this case to like making sure that you're checking what's coming in, you're validating your stuff. So one of the trends you'll hear tonight with me talking on this is just do not trust users. No matter what they send you, whether it be directly something they type in or something they send you in a cookie or a header, all of that can be manipulated. Do not trust anything from the user side. Assume it's all bad and all out to get you. You're not paranoid if it's true, right? That's how it goes. So, and where possible, don't work with deserialized data or serializing data. That said, I'm not joking. An hour and a half ago, I sat down and was writing code about serializing data for Project Hammer. Okay, but what did I do with that? Well, that's got a hash. It's got a hash attached to it, so I can check, has it been manipulated? Only our side knows what the salt is on that, so we can protect that and validate it. We know the data structure, and we can work with it in a safe way. We're using a safe parser to deserialize it, because we're doing all these checks that you should do. And so we have a high confidence on that. But it can be very easy for this to kind of happen on any project where you're just copying code off Stack Overflow and it seems to work, right? So it really does mean like looking into this. And if you think, wow, nobody would fall for this, it's 2020. Here is a screenshot from Oracle about Oracle servers that literally had this exact problem, where they had a deserialization bug, and it led to remote code execution. And that was from this year. This happens to everyone, really tricky, you know, so it's something you should look out for. Right, so let's move along to cross-site scripting. When I originally built the slide deck a while ago, I thought, oh, cross-site scripting, that's a web thing. I don't have to worry about that one, because I don't build a lot of like web stuff. I work on backends and big servers and things like that. But I'll get to why it probably impacts you every day of your life now in a moment. But cross-site scripting is really interesting because there's many layers to it. In a moment, I'll show you a demo of reflective cross-site scripting. This is the one we always think about, where you sort of send some data to the server and it immediately sends it back to the user. And hey, look, I got the server to do stuff it shouldn't, or got the browser to do stuff it shouldn't. There are risks in that. There are security holes in that. In my mind, it's a lesser problem than stored. So storing it is like a cross-site scripting attack is I put something in and it goes and gets into a database and then gets read somewhere else. So you can think of an attack scenario where I'm logging a support ticket, right? And so I take that ticket and I put in some cross-site scripting stuff, and then the support engineer opens it, and boom, I'm now running as the support engineer. I have all their permissions. And you think, well, but what can I do with that? Think back to the recent Twitter attack where they were all, all the famous people were tweeting about free Bitcoin, right? How did that happen? It wasn't from cross-site scripting, but it was from getting access to the support users, okay? If they were using some sort of system with a web UI, it's possible they could have been attacked by cross-site scripting. So stored is really dangerous, and particularly because it's so long-lasting. DOM cross-site scripting is another level down on this. This is where an attacker can get in between your backend and your front end, and your backend sending some HTML or some content to the front end to render. And we do that more and more with like React and all the fancy JavaScript applications we build now. And if they can do that and intercept it, then they can put whatever they want into that and really take it over. So cross-site scripting is a fairly big problem. But I did say I'd show you a bit of it. So this is the OWASP Juice Shop. It's a sample app that OWASP has produced, and I love it to absolute bits. It's a great way to learn about these. It's designed as like the training ground for this. So there are like Xbox style achievements in here when you hack something, which makes you feel really good. And it's set up in such a way that it's really easy to work with. They have hosted versions. If you want to run your own, it's like 5 clicks and they'll deploy it to Heroku, and it's totally free. There are some attack scenarios that you need your own one running in a VM, but you can get up and running with this in 20 minutes and be, successfully hacking and learning things. It's a lot of fun to work with this. So I'm using this for a couple of our demos today. And all I've done ahead of time, besides the stock standard install, is I've created an account and I've added a credit card. Not that it will be important for this at the moment. But what I want to do is just show you some sort of reflected cross-site scripting and sort of the trickiness of it. So I'm going to go up to search, and I'm going to search for oranges. And that will then, whatever I type in there goes into the query string. When my browser wakes up, it will then reflect out orange there. And so now as an attacker, you might go, ooh, that's going to be good. I've got some cool cross-site scripting to drop in here. I will drop in a script. Actually, let me go here to the console just to show you what that looks like. No, stop that browser. All right, so I'm just doing like a normal JavaScript tag here. Script alert. If I can get the alert to pop, I win. That's how the game goes, right? So let's hit that, and look, nothing appeared there. I wonder what's happening. Well, in this case, whoever wrote this is very clever. They look for the word script, and so if I just remove the S from it, I can get that to go there. These smart people who built this have completely stopped cross-site scripting, except that's the problem. There is like 9 million ways to run JavaScript. So I can go in here, and instead of doing this simple way, I can drop in an iframe and have the source of the iframe be JavaScript. I don't know who built browsers and why they thought this was a good idea, but somebody did. And I can do that. And now I've got past the script tag pre-approved like words, and I've popped up an alert box. Huh? Yeah, and I got an achievement. That's a good night. Like, it's that easy to do these sort of things. And it's like, how did I do this? Do I know all about cross-site scripting? Not particularly, but there's like GitHub pages just with thousands of example ones, and you can go and pull these out and go like, oh, I wonder if this type would work. I wonder if this attack will work. Can I use a video tag? Can I do this? There are so many opportunities for that. It is really hard to do it. So once again, do not trust anything you get from the user, including things they pass in from URLs. If you are going to render stuff, always HTML escape it just in case. Doesn't matter where you're putting escape it. Make sure you use safer formats if you do have to accept user input, so like Markdown. Make sure, and then there are some other good advice on this. Use audit tools. You can use technologies like Pause or CSP to make sure it's only your JavaScript running. And you can also use make all your cookies HTTP only, so they're not readable by JavaScript. And that will then make sure at least you're limiting the blast radius on that. Cool, so let's move on to the next one, which is security misconfigurations. This is once again a bit of a like, you know this, you're smart. I know you know this, and you know this. Get your setup right. Make sure you're not running things on your server you shouldn't. I had a scenario a couple of weeks ago where I was looking at somebody's prod service and they had the Java like debugging environment on them, so developers could remote it with like could connect IntelliJ to it. And I was like, I'm sure this is not going to go horribly for you. Yeah. So don't have stuff on your machines that aren't needed. Don't have all the ports open. Make sure you're not using default credentials. Make sure your error messages don't return just like too much nonsense. The OWASP one is store app really great when you see its error messages. If you can get it to make an error message in a REST call, it's amazing. And calling back to like issue number 9, don't use code with known vulnerabilities, right? This is really just getting things correct. So obviously don't trust anything you get from users, but you know, there are other steps you can do. Make sure you get your security audits done. Get your staff to go on security training. Like there's always new things to learn. There's always content available to improve. Automate as much as possible, remove things as much as possible to get your configurations nice and tight. So now we move on to number 5, which is the broken access control. So here we are caring about there is authentication, authorization, which I find is kind of useful here. So authentication, who am I? Authorization, what can I do, right? So we're really focusing more on authentication here. Well, maybe authentication or authorization. Maybe I can get in, but then I access somebody else's details, right? I can edit a URL and get access to something. And that sounds like, oh, who would do that? The very first thing I ever built in a paying job as a developer was for a hosting company, which if you're young, it's what you used to call the cloud before the cloud was cool. And I built a web mail front end with a proper username and password, and it would check is that the right username and password, and log you in. But I needed to remember who you were, so I put your email address in the URL. And the first person who saw it changed the email address to mine and then read my email. I was young and stupid, right? Like I didn't know better. So these things can happen. Another good example is IDOR's indirect object references. I will show you a good bit on that in a second. But that's really just like, hey, my database, I've got primary key 1, 2, 3, 4, 5, and I see it like 1, 2, 3, 4, 5, or like a 1 in the URL, and I change it to 2 or 3, and then I see somebody else's details. So these can happen, right? Don't trust user input again. Doesn't matter if it's in the URL, don't trust it, right? Make sure you deny by default. Make sure you're checking in depth. So if I ask for account number 5, it should check, is this account linked to me before it returns it? Okay, and it does that in-depth checking. I've got a screenshot here from the eThekwini municipality in South Africa who leaked 100,000 residents' details because they literally had everyone with like an integer in their system. So somebody just went like 1, 2, 3, and just toggled it on the website to see everyone else's details. And one of the things, even if you have that you can do to just sort of limit the blast radius is to have rate limiting. So rate limiting is just like slowing everything down. Here they had none of that, so they just lost everything really quickly. Rate limiting at least kind of will help you out a bit. Moving on to number 4, which is XML external entities. This is kind of a focus on the deserialization problem again, where we're getting some input and we're working with it. But this is really focused on features of XML parsers that may be left on or that you don't know about that can be used to attack you. So let's have a look at that. This is an example one I've got here, and I'll get my pen out here. This uses stuff I didn't know about. Here's just some normal XML tags at the bottom, but this piece in the middle, that's a variable. I didn't know XML had variables. I don't know why that's a thing that's needed, but obviously it points up to here, and it says load the variable from the file system, and that's where you can read the data. And so it'll replace that variable with the contents of your parser file. Like it's that simple. I don't know why this is needed, but turn this off if your XML parsers do this. And there are lots of ways to do this. Another good one here, this is doing the same thing with YAML. So each line, I start off with assigning 10 lols, strings to variable A, and then I assign 10 copies of that to B and so on. So in the last line here, you can see I've got 1 billion lols. So this is what's called the billion laughing clown or laughing clown attack. And with this is like an amplification attack. So I send a very small payload. I send just this. And then whatever you're using to parse XML or YAML in this case has to deal with 1 billion lines and then it crashes. And so I've denial of service attacked your server with a very small payload. This is like really scary for me because these are so sneaky and hard things to do. And if you needed another reason to hate YAML, I'd at least give you that much for the night. Right, so on to number 4. I'm ahead of my timer for some reason. Oops. Right, so I'm still on number 4, that's why. Don't trust user input. Make sure you use static analysis tools. Make sure you have dependency checks. If you are using SOAP before 1.2, make sure you use SOAP version 1.2 or above, because the old versions required this, and just turn off any features you don't need. So number 3 is about sensitive data exposure. I couldn't have picked a better day for this one because this is just magically timed. So this is about, getting access to things you shouldn't, right? This could be like if you're going to pick on AWS, the S3 buckets with everyone's stuff backed up into it. Now, that's actually a sensitive data exposure, but it's also security misconfiguration from earlier. Your bucket shouldn't be like publicly readable on the internet. Who thought that was a good default, right? So don't have that, right? That's just bad configuration. Another good example of sensitive data exposure, man-in-the-middle attacks, people connecting to like dodgy Wi-Fi's and coffee shops and getting attacked there, right? Or sharing data that should be private. So I'll show you a good example of this back to the juice shop here. And I'm using my favorite hacking tools, Microsoft Edge, because who doesn't like Microsoft Edge? And I've got the network tab open there. And what I'm going to do is go to my account. And I mentioned I added a credit card earlier. I am worried about security about this, just so you know. So I didn't add my credit card because that'd be crazy. I'm going to show a credit card number publicly. Better make it somebody else's. So let's load that up. And you'll see when it comes up here, it's done it quite nicely. It's got like only the first 4 digits and then star, because, obviously if somebody could compromise my account, they got my password because I reused it from somewhere or something like that. That would allow an attacker to, see all my details. Where is the card gone? Oh no, it's not there. I'll add it again. We can show it. Oh well, I'll add my real one. Just close your eyes while I type in my real credit card. I'll tell you when you can open them. I trust you. You're on. This isn't recorded. Oh wait, this is recorded. We'll get somebody to edit it out. It's fine. Yeah. Anyway, so it's going to come up. It's going to have stars. Cool. Like it's protected. If somebody gets access to my account here, they can't get my credit card, right? Like it's all nice and secure. Today, internet would be good. I have a timer. You're just doing this because you don't like me now. Anyway, we'll give it another second. But what's actually happening behind the scenes is that's just a purely visual aspect, right? That's purely something that's only on the UI side. Behind the scenes, crossing over the wire, is actually the credit card details. Oh, I'm somehow unauthenticated. I'm not logged in anymore. That's why. Okay, you'll just have to take my word for it. I do have a 90-minute YouTube video with all of these in if you want to see them done slightly better. I say this is a really great day to do this because if you are interested in something, I'll put it in the chat later. There is this magnificent article. You can see it's pretty long. There are no comments on this. This is the whole article. It's about how somebody got the Australian Prime Minister's passport number. And if you go through this long article, they did it this exact way. They literally just saw what was crossing the wire using their favorite browser of choice to see that. And it was just passed there. It wasn't shown on the UI, it was just passed there. So that came out today or yesterday. It's a really great way of this is how vulnerable people are. And privacy stuff gets compromised all the time. So yeah, make sure you encrypt everything in transit, obviously, even internally on your networks, just in case you have a malicious attacker inside your network. Make sure you encrypt everything at rest in case it gets leaked out somehow, like the files. Make sure you use things like HSTS preloading so you don't have potential for attacks during the handshaking for your HTTP websites. And only store and share the information that you absolutely must store and share. Nobody's going to clap for me at the end. I can see this now. I've got 4 minutes. Right, two sections in 4 minutes. We can maybe do this. Right, number 2 is broken authentication. This is pretty simple, default admin accounts. This is things like people brute forcing your site because you don't have captures on your login page and rate limiting, things like that. It can be as simple as plain text passwords. There are still many websites that store their passwords in plain text. And when they get compromised, if they're doing that badly, they're going to get compromised in some other way because they're not looking after it correctly. And if you want to sort of brute force a website, this is as complex as it gets. This is, uses a free tool called Hydra, which and a password list called RockU, and smashes at the OWASP juice shop in a few seconds, and will break you into the admin account. It's not complicated at all. So what can you do about it? Like, if you can, don't build auth. Rely on like something like OAuth for that sort of stuff. If you can, it's in your control. You know, use things like rate limiting. Have your systems check for compromised passwords on the websites like with data like haveibeenpwned.com's passwords. Avoid knowledge questions. Because those are also compromised. So I've got this one here. Let's move this window out of the way for a second. I got this from Twitter. And this is one of these things where you find out your royal name. So in my case, Lord, my dog's name, Chakalaka. And the last thing I ate was something. I don't remember now. And cool, like, aha, funny tweet. But now I can associate your tweet with your pet's name, and pet's name's a common knowledge question. So now I can try and attack you that way. Like, these things are terrible. So don't have those. Implement two-factor auth, right? Get your users to use it. The juice shop website, one of the accounts you're going to take over is protected with two-factor auth, and one of the accounts isn't. Guess which one's the easy one, right? And also, you know, so there's a lot of good advice that you can do with these sort of things. Slides are available if you want those. And lastly, we'll get on to the number one issue, according to the OWASP Top 10, is injection attacks, right? This is in a way still the deserialization problem, right? Like, we're shedding some data, but here we're tricking an interpreter instead of like a parser into running some stuff it shouldn't. Obviously, we are all kind of aware of like SQL injection as an attack vector, but this can be to anything. You can use this by passing stuff through environmental variables or headers and have it manipulate like built up strings in your code. So once again, don't trust user input. If you are going to use SQL, make sure you use SQL parameters. Don't put strings together. Don't put strings together anywhere in your code with just like straight up accepted user input, because that's never going to go right. Make use of approval lists for content. You know, if you're asking for an email address, don't accept quote characters. Why are they there? Who knows? And OWASP produce a really good tool called Zap, which will help with like finding these, and you can embed that into your pipeline for your deploys, so you can automatically scan your sites for SQL for injection attacks. So it's really useful. So are we done? I have 30 seconds for one slide. No, this is literally the minimum bar. If you do all this right, awesome, you're doing well. But now go further and start getting better. If you're not doing all of this, you've got a whole bunch of new work items for tomorrow morning, which is really useful. Join your local OWASP group. They're really, really useful. They do a lot of good work. Make sure you run along checks all the time. Get a red team. These are one of my favorite things. Like, they not only try to physically attack your networks, but they'll try attack your staff and like social engineer them or break into your building. You will learn a lot about how secure your stuff is. And yeah, keep practicing. The last thing you want to do is be woken up 2 in the morning and not know how to respond to a security vulnerability. Make sure you practice it. Have everyone in your team, every developer, every QA, practice a security incident. Know who to speak to, know who to respond to. Not only in your like dev teams, but also get your PR teams. The number of people who are running like Twitter accounts who don't know how to deal with security reports is scary. Just teach them to like, oh, it's a security report, wake me up and I'll deal with it. And not me personally. I mean, wake up Steve Morgan. I think he's better at 2 in the morning anyway. And lastly, you know, making sure security is your first principle is always a good way. So with that, is me done. I am 45 seconds over. I do not expect any claps or applause. And now we'll do the panel discussion.
I'll give you some claps and applause.
Thank you. You're way too kind.
Thank you, Robert. That was awesome. Really, really awesome. We're now going to go on to our fishbowl. So we do have Grant and Zoe and Brian also joining you. And we have a couple of questions. Let's see, the first one is from Danny H. Oh, it's a one about trust. Should we trust internal users? Example, an employee of the company needs to use a web page which is hidden from customers to add records to the database, and the column the data is stored in is of a data type blob or text. Trust not trust?
I'm not sure I really understand the risk. I mean, I wouldn't trust I trust internal users more, but I mean, there are really common attack vectors, right? Sometimes you get grumpy staff. You get staff who are compromised, who get paid. In my previous lives, I've worked for AWS and I've worked for Microsoft. And I've long held that I'm pretty sure like nation states are putting staff into them. Because why not? Why wouldn't you, right? So should you trust them? I trust them more than I trust people on the internet because it's just harder, but you should still have good security. Don't let people on your own internal staff like have access to prod databases if they don't need to, because they'll get compromised and they'll get in. Try to make sure that you have like good front-end tools. Going back to the Twitter example, who thought it was a good idea to let support users tweet on other people's accounts, right? There's like no good use case for that. Have like 3 layers of checking, and they have to get a manager sign in if you really need something like that. Because if they get compromised like they did at Twitter, then that's how they get in and get like completely wrecked as a company.
I think it's also about the principle of the thing. It's data coming in from outside something that you created. It isn't data that you are manipulating within your program itself. It's something that comes from outside, whether it's internal users or anything else. It doesn't really matter. It falls outside the security boundary. You should validate it. Just a simple rule, right?
All right. I never find trust really simple, so thank you, Grant, for that, making it binary. It's really simple, and it's always about boundaries, isn't it? We have a question received in advance of the talk. What do you think about the top 10 being taken as a standard by things like the PCI-DSS?
That's a interesting question in that respect. So the top 10 was originally built as an awareness document. It was back in 2003. We're trying to get people to start with something because it was a growing field. And so historically, I've been more on the fence of I'd rather it not be in standards. However, we didn't give them anything better. And so at some point, being in the PCI has actually made an absolutely enormous difference within secure development. And that was one of the things that, for me, the top 10 being one of the more well-known projects for OWASP, it is actually that place where you can, and it has that level of influence and it has that power now that it's part of standards to actually make a difference, which is really what people collect in OWASP to do, and that is to make a difference in the larger industry, not just in their team and their company, but to do it on a global scale. So it took me a little while to get swayed, but at the same time, I think it's a really good thing to be part of those standards, but it also means there's a huge responsibility for what we curate into the top 10.
And I think that's actually a great answer, Brian, because that's actually the point of it, right? It is a curated list. It comes from industry. It's what you guys are seeing as the most common vulnerabilities. It's not these are the things you must do. These happen to be the things that people are generally seeing vulnerabilities come out of.
So yeah, in 2017, so 8 of the top 10 came out of data that we had companies submit. So we had 114,000 applications represented in that data. So we had, so we took prevalence. So we left frequency. So frequency, sorry, I'll sidebar just for a second. Frequency is usually how many times you see something in an application. So cross-site scripting will typically have a really high frequency because if you didn't do anything to defend against it, it's going to be incredibly prevalent in your app. It'll happen all the time. But tools are really good at finding things at a high level of frequency because when you ask a tool to find something, it will tirelessly find every instance of that you possibly can find. When you ask a human to test an application, they find 3 or 4 instances of cross-site scripting, they're going to stop because their time's more valuable than that and they need to go look at other things. So in 2017, we switched the top 10 to incidence rate. So we went a little more with the methodology and terminology of epidemiology. So incidence rate is basically what percentage of the population exhibits something. And so we went for, we don't care how frequently something happens in an app, we care how many different apps does this type of vulnerability actually occur in. So we have that level of incidence rate, but then we also combine that with the potential impact on average. So knowing that the impact can vary per app, per situation, we also, given the 4 of us that are all co-leads in the top 10 team, we have a ridiculously high number of years of experience of doing this. And so a lot of that just put down and said, all right, so from what we've seen, what we've talked to, what we've experienced, what is the most common, or where would we, what's a baseline for impact for something like this? So that was 8 of the 10. And then 2 of the 10 were actually from an industry level survey. So we had 550 people that were related to AppSec chime in on what they felt were important issues that were CWEs that may not be reflected in data. Because the one thing to remember is we can do this by data, but we're always looking behind us because it's stuff we've seen in the past. And we also can only record what we know to test. So if we don't know how to test something, or we're not really good at testing something, we won't see it in the data, but it might be there. So we decided that 2 of the 10 needed to come from basically people's expertise that may not be represented in the data. And that's where the insecurity, serialization, and insufficient logging and monitoring came from. They're basically a bunch of experts said, we see this, we're not sure it's represented in the data. And so that's how we got to the top 10 in 2017. And we're doing something similar in 2020. At this rate, judging by the people who have responded positively for the data call so far, we will break that 114,000 application. And the hope is to really have the largest collection of public data for vulnerabilities that we've seen yet.
Thank you. That was a great, clear answer. I learned so much. All right. Let's see. Some people say you should return a 404 when someone tries to access something they do not have permission for, so that an attacker can learn what the system contains. Are they misguided, or is this sensible advice? And this is from Ali. Thoughts, opinions?
Yeah, I'll take a stab at it. It's one I fight often about, like, how much do we return back? Because every piece you return is information, right? And that can be useful. So if somebody has a login problem and you return a different error code per login, that's an issue, right? A really great example of this is like even simple things like forgot password forms can be attacked. So there is a website, Adult Friend Finder. If you don't know what it is, don't worry about it. Just assume it's a website you might not want to be associated with. Their forgot password form on it, if you put in a real an email address that didn't exist, it would go, email doesn't exist. And if you put in an email that did exist, it would say, we sent you an email. I didn't have to hack their website to figure out whose email's on there, right? That's security vulnerability. Mm-hmm. It is also really good UX, right? Because it's now making it easier for the user. And so sometimes you're going to have those trade-offs and you're going to have to make those decisions. You can build really secure systems by turning the computer off and burying it in concrete, but it's not useful. So ultimately, you're going to make trade-offs. It's about how much risk you're willing to take, what you're building, what other things you can put in place to protect you, not relying on any one particular thing. Would I return back 404s specifically on errors or things like that to attacker? Probably not, because I value people calling my APIs and their experience really highly. And if you know, oh, this exists, but I don't have permission, hopefully the other security aspects still apply and are still good enough there. Would I return out like stack traces to users if they get an error? No, because that's like somebody will use that to get into the system.
We have an error code.
It's a really interesting question when you come, because you're trying to balance security with usability. So it's interesting, like if you look at GitHub, if you don't have permission to something, they'll give you a 404. And from a user's perspective, I'm left with wondering, did I mistype something or do I not have permissions? So it's an interesting challenge. Absolutely don't tell them more than they need to, but at some point you really don't want to harm your user experience. And so it's a very interesting balance. And some of it has to just do with knowing who your user base is. Are they more advanced and you can do that to them? Or are they more basic internet users and you need to be more friendly? That just means you have to put other layers of security in place, because you do end up saying a little bit more when there's errors.
Excellent. Let's see, from John, which tool should we use for pen testing of a website vulnerability and infrastructure analysis?
That's a loaded question. Depends what you're trying to test, what kind of languages. I mean, like Grant mentioned Zap earlier, and Robert did too. Zap and Burp Suite are also really good. Developer tools and browsers are actually good.
All right. I want to try to get through these questions. How do the programmers keep into data with new security vulnerabilities and attacks?
Join OWASP is a good first one. I can say that because I'm not, one of these distinguished smart people here. I'm a normal person, so that I'm not getting paid for that. So OWASP is a good thing. I mean, it's like everything else in software development. It's taking time, right? There are many great resources out there, from like official things on like Udemy training down to just, I've learned so much from listening to security podcasts and things like that. Just taking an hour a week to listen to .NET Diaries as a good example of like, oh, here is some really weird attack scenarios and what people could do. And just that spurs some interest, and then that leads to more stuff. That's a good option. Another I mentioned in my talk is like red teams. Just get a group of people to come and attack you. You'll learn really quickly where all your holes are, and your developers will skill up really quickly when they're constantly under threat of being attacked and the system being attacked.
For me, I have like a curated Twitter feed. Absolute AppSec's a good podcast as well. It just takes a little bit of time. I try and spend at least 30 to 60 minutes a day just trying to keep up with what's going on in that space.
Also, some of the stack exchanges, the security related stack exchanges, can be super helpful because it's per scenario and it gets very specific. And sometimes, one answer isn't in of itself complete, but they kind of feed off of each other. So in general, I feel like that's a good option. And the OWASP Slack channel itself, because it has various people's feedback, you can ask Q&A, maybe get a direct response, or maybe just reference something previously mentioned that kind of all feeds into a discussion, and from OWASP.
Great. From Sam, could you give an example of how practicing works in real terms? Like, do you plan a day of it or just throw something random into the system one Friday afternoon, then see how the team responds?
Not Friday. Don't do this Fridays. Do this Fridays at the peril of everybody involved, especially in Cape Town.
Mondays, Tuesdays?
Yeah, Wednesday's good.
Okay.
Right in the middle, like it.
From my experience on this, what we've always done is with new teams is start off with like coordinated things. So tell everyone we're going to be doing on this day. It's going to be at this time. Have somebody run it. They make really good team building exercises. You have somebody screen sharing and dealing with it. Everyone jumping in. They're a really great experience. Normal chaos state testing that you would do even as a developer can be focused just on security. once your teams get more mature and better and coping with it, yeah, unexpected ones, you could go the full Netflix chaos monkey route and have it happening for you all the time. Though maybe not Fridays and weekends. Nobody needs that sort of attack.
Okay, then from Veronica, how do we empower developers to develop applications with more of a security-based mindset? Interesting. What are you guys doing? What are you seeing out there?
That's a challenge, because that's organizational level. I mean, because you've got to give them resources, you got to give them time, and you have to give them priority. Because if developers are paid and their goal and vision that have been given to them is simply to get the business features done, only the rare one will be able to go out there on their own time, figure out what they need to do security related. If it becomes a priority for the culture, some of the coolest company cultures I've ever worked with, it was a good thing to spend time to develop a security champion, to be able to go to training classes and view your own classes, and it was supported by the organization. If you don't have that support, that's incredibly difficult to do.
I would think the usability too would be hard, that decision making between usability and security. You need lots of collaboration.
So I like to replace the word security with performance in any question like this, because security is a non-functional requirement of our system, right? So how do we empower developers to develop applications with more of a performance-based mindset? It's culture, as Brian said. Developers have to want to make things more secure or more performant. Developers have to have the skills given to them, passed down by other developers, or learned as part of a classroom activity, hands-on training activity, pair programming, however you transfer knowledge about a particular aspect of software to other developers. And then it has to be valued by the people who make the decisions about, yes, let's do this, let's not do that. If the product owner of a system doesn't care about the security things, they're going to get pushed down on the list, right? The product owner doesn't understand why they're important, they'll never get dealt with. So it is about ensuring that everybody understands that security is a non-functional requirement and setting whatever that bar is, right? I mean, we don't all write the most performant systems on the planet. We don't all have the PayPal problem, right? So we don't all necessarily have the same requirements from a security perspective, but make sure that you balance that. Make sure your developers know what your culture for security is.
That's a good call. And depending, especially, for example, smaller, earlier stage startups, I've found that just integrating it from the hiring, from the moment you hire, will they be willing to learn security for the benefit of the organization and to not put it at risk? And it's just the general model of incentives and culture. So, at that point, this is definitely an HR issue as well, to some degree.
Thank you. We have one last question, but before that, I think it was you, Brian, that mentioned a podcast. We have a request to our panelists. What was?
Oh, to restate? Oh, it was the Absolute AppSec.
Okay.
So
Absolute AppSec.
Yeah. Ken Johnson and Seth Law.
Perfect, thank you.
AppSec podcast is also good with Chris Romeo and Robert Hulbert. And the Darknet Diaries was also earlier mentioned.
Security Weekly.
Thank you, Zoe. What's that?
And Security Weekly. There's a bunch of good podcasts out there. Follow some people on Twitter that you trust their recommendation on and ask them. And you'll get 100 responses and probably never have enough time, especially as we're no longer sitting in the tube, to listen to all the podcasts you are keen on.
Yeah.
Cool. We're going slightly over just because we got a little bit of a late start. One last question. I like ending with this. Are there many security issues that weren't covered by the OWASP Top 10?
No, it's just 10. It's that simple.
That's it.
10 and 9. There's no need for more than 10.
Yeah, I mean, no one tells anyone, but there are like a lot, and then OWASP picks 10, and we'll stop doing the other ones from the next list. That's, I think there might be lost count about 1 billion of maybe 2 billion different ones. It's just, and maybe I'm missing
a small number, a small number.
Small number. There's just so many, and they're all, every month there are some new interesting, there are based sort of common things, and then people do interesting spins on them, and it's, yeah, there's a lot.
Yeah. So yeah, and I don't want to go down the road of like, hey, you'll never catch up. You probably will never catch up. But like the top 10 covers somewhere around 30 some CWEs total. There's somewhere around 800 or 900, I think, right now. And these are just more, these are the general common weaknesses, not specific vulnerabilities, but more classes of them. But when it comes down to it, I mean, you can't protect against everything. That's why we have layers. But you also, you know, everything you can do to say, how do I know the user is who they say they are? How do I know that they're supposed to access or perform some action on this resource? And I don't trust input by default. I mean, if you do that level of, that's 80 to 90% of the issues you have, all root from those 3 points. Because when I worked at FedEx, we boiled the top 10 down to the top 5, and it basically became, if we could do authentication, authorization, input validation, logging, and crypto. And by the time we got through those 5, we had 90-some% of everything covered with that. There's a lot of other things that are fringes and edges, and you can't do all of them, but really most of the attacks and the breaches we find are from basic hygiene. It's stuff that had you had solid plans, programs, frameworks in place, you could have prevented the vast majority of them.
All right, I think that is a wrap for today. Many thanks to everyone for their questions and everyone else in the audience. I hope you found it a really useful session. A special thanks to you, Robert, Grant, Zoe, and Brian. It was a great discussion. Next week, please join us for our series around security gamification, the threat of modeling using OWASP cornucopia with our very own Grant Ungers right here today. You heard from him, security consultant at EqualExperts. He'll be introducing OWASP cornucopia and the simplified OWASP top 5 for developers. So sign up, and we look forward to seeing you next week. Have a great evening, and thank you.